In this video, we'll talk about two different ways to calculate the product of a matrix and a vector. So the definition that's often given is if you have a matrix, let's just look at an example. Let's say that A is this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's say that X is this vector x1, x2, x3. Okay, so X is just some random vector. It's not a specific vector with specific numbers. So the way we defined A times X is we used, remember we took, what you do is you take x1 of the first column and add x2 of the second column and add x3 of the third column. So what that ends up being is x1, so remember x1, x2, and x3 are scalars. So x1 times 147 plus x2 times 258 plus x3 times 369. And that ends up being, so remember the way you define a scalar times a vector is you scale each of the components. So this is going to be x1, 4x1, 7x1, plus 2x2, 5x2, 8x2, plus 3x3, 6x3, 9x3. And now you add the vectors by adding each component. So this will give you the vector x1 plus 2x2 plus 3x3, 4x1 plus 5x1 plus 6x3, 7x1 plus 8x2 plus 9x3. Now there's another way to get this result, which is, if you're familiar with dot products, so you do this to get the first component. So this is going to be a vector with 3 components, right? What you do is you take this first row and then do the dot product with that with this vector. So what that means is you multiply the first number with the first number here, and you multiply the second number with the second number here, and then you multiply the third number by the third number here, and then you add them together. So you're going to get 1 times x1 plus 2 times x2 plus 3 times x3. That gives you x1 plus 2x2 plus 3x3. So that's the first number of the resulting vector. And then define the number that goes here. What you do is you look at the second row times this vector. So that gives you, so you take the first number, multiply it by the first number, and keep going. So that will give you 4x1 plus 5x2 plus 6x3. And then finally, for the last number, you take the third row and then multiply it by this column. So you're going to get 7 times x1 plus 8 times x2 plus 9 times x3. So 7x1 plus 8x2 plus 9x3. And that's, in fact, the same as that. And in practice, when you're multiplying a matrix times a vector, you usually use this way. So the second way. So let's, and in many books, this is actually how a matrix times a vector is defined. So let's just do an example, just to get used to this. So let's say that you had 1, 2, -1, 0, -5, 3, times 4, 3, 7. Well, why don't you take a minute and see what you get? Okay, let's go over the answer. So what you're going to do is you're going to take the first row and multiply it by the vector. So it's going to be 1 times 4 plus 2 times 3 plus negative 1 times 7. That's going to be the first component. And then the second component is 0 times 4 plus negative 5 times 3 plus 3 times 7. So this is going to give you 4 plus 6 is 10 minus 7, that gives you 3. And then 0 times 4 is 0, and negative 5 times 3 is negative 15, and then plus 21 is 6. So you get 3, 6. And I just want to mention that this matrix A, this matrix, is a 2 by 3 matrix. Right? This is a 2 by 3 matrix, and then this vector, which we're thinking of as a matrix, this column vector can be thought of as a matrix, which is 3 by 1. And in order for this matrix times a vector to be defined, the middle numbers have to be equal. Okay. Let's look at one more. Okay. Well, let's look at one more example. Let's say you take this matrix. This is a special matrix called the identity matrix. A 3 by 3 identity matrix. So this matrix is called the 3 by 3 identity matrix. And what happens if you take this matrix and multiply it by this vector x, y, z? Well, what you're going to get, let's use the second way of multiplying it. You're going to get the components are 1 times x plus 0 times y plus 0 times z. That's just x. And then you're going to get, for the second component, it's 0 times x plus 1 times y plus 0 times z is just y. And then the third component is 0 times x plus 0 times y plus 1 times z is z. So you see that this matrix times a vector gives you the same vector as the result. So it doesn't change the vector at all. So this is called I. You sub 3 to indicate that this is the 3 by 3 identity matrix. So notice that I3 times x is just equal to x. Right, so here's your vector x, and then the output's also the vector x. And in general, IN is the n by n identity matrix, which is defined to be, it's the matrix Aij, where Aii is 1, and Aij is, oops, I wrote that too fast. Aij is equal to 0 if I is not equal to j. And this matrix has the property that IN times x is x for all, for every x in Rn. Okay, that's all I wanted to say in this video. So in this video, we went over 2 different ways of multiplying matrices. The one way, using the definition, which is to take linear combinations of the columns. This way is more important for understanding the theory, I would say, behind linear algebra. But in practice, if you have 2 matrices and you want to multiply them, or a matrix and a vector, and you want to multiply them, you typically use this way with the so-called dot product with the row and the column. Okay, thanks.